And actually, I'm going to talk about quality in a perspective beyond testing as well. So we're talking about the Agile quality pipeline, or how to go from fear to confidence by continuously making the least imperfect choices. And I won't talk about what can be done necessarily in general terms. I will more talk about what we actually did in the latest project I've been involved in. But I will try to do it in a generic way to avoid boring you with too much details and so on. So for the last 1.5 years, I've been involved in a project tasked to create a new public transport ticketing system from scratch. And the goal set to us, the team, by Skånetrafiken, who is sort of a government-owned public transportation company in the southernmost part of Sweden, was to make a ticketing system that could handle around 60 million tickets per year and 600 million ticket events like validations and refunding and so on, and 300 validations per second on buses and handheld devices and so on. And the task was to do this more cost effectively than the current system that is running right now. So what do you need to get decent quality levels in a modern Agile project? Well, first of all, you'll need a quality assurance strategist, someone like me, perhaps. And just a short presentation halfway in. My name is Tobias Anderson, like we said. I'm from System Verification, and we're a company that have our headquarters in Malmö, Sweden. We also have offices in Gothenburg, Stockholm, and also with constantly growing importance, Sarajevo. This project at Skånetrafiken, when I was introduced to it, it was early days. All we had were some PowerPoint slides and an Excel sheet listing the high-level features needed to accomplish what was in those PowerPoint slides. So the first, or one of the first meetings I attended was an estimation workshop with only 3 people. It was me, it was a requirement specialist, and a software architect. And the only reason I was brought in this early, because as we testers know, we generally are introduced late in projects, every type of project, even if it's an old type project or an Agile project or whatever. And normally we get introduced late, but this time I was from the very beginning, and the main reason was that I was available, and the company that was tasked by Skånetrafiken to create this new ticketing system, I've been working with them before, and they knew how I worked and wanted to work with me again, and I was available now and not in a couple of months when they actually wanted me to come, so I had to come early. So I was sitting there in that meeting, and in the beginning, in general, just listening in on conversations. And for a while I zoned out, and I was thinking that, well, now that I'm here in the beginning, what's my excuse to not make a good job out of it? Because, like it says there, a normal excuse that we have is like that we can't make a good job of quality assurance because we're brought in too late. All the time we're brought in too late. And I was brought in from the beginning. I had no excuse. I had to sort of try to make a decent job out of it. So I was thinking, how should I make that possible? And in that meeting, or in one of those meetings where we discussed the requirements and the estimations of the efforts for developing all the features needed, I asked the other ones in the room, when I'm here, why don't we just estimate the test efforts at the same time? To include the test efforts as we include development efforts. So I would say that making an early effort to include quality assurance in the development process is key to gaining confidence in the product quality. And this also lays the foundation for making quality assurance and the testing perspective a first-class citizen within the project. I will talk a little bit more later what I mean about quality assurance being a first-class citizen. But apart from estimating early, we can also bring our thoughts on design early in the product development. Design for testability, how to make sure that the product we're building is testable in an easy way. So we have, for instance, user interface. To be able to test that automatically, we need to be able to identify elements in the graphical user interface, buttons, images, and so on. We can't look for it with image recognition. We need to identify the underlying components. And by being able to be a part of the early design discussions, we can add those elements to the design. And the same thing goes for backend development, servers with APIs and endpoints that we are supposed to test. If we have something describing the entire API in a definition, something like a tool like Swagger or Protobuf from Google, if you know those type of things. There are tools that describe APIs, and then you can import that description and auto-generate C# code from that to make object classes that we can then use in our test framework to be able to execute tests. And this is very powerful. But apart from these type of tools, we also introduced specific endpoints just for testing. We had early discussions on specific testing endpoints, because every time you introduce something for testing, you introduce risks. So we also made sure that we tested the test stuff in the code. So we made sure that test endpoints weren't available in production environments and so on. So we had test endpoints, for instance, for setting the clock on our ticket creation service, and our validation service, so we can emulate time passing. So we can create a ticket and emulate it being out of time scope in a matter of milliseconds instead of waiting a year, which is quite ineffective. Also, in a design perspective, to design with portability in mind is very important for the quality assurance perspective, because if we can multiply our environments or create more environments for specific needs, it's easier for us to do our testing effectively and efficiently, especially the development of our test efforts, our test scripts, and so on. So if the software is easy to, for instance, a big backend, so in our case 6 or 7 smaller services that we need all of them to work together, and we need isolated environments of every one of them. And if portability has been a part of the design, then we can easily create a new environment if we want to test something specific, and then we can just tear it down again. especially if you're working cloud-based like we were. And these things all contribute towards the goal of having quality assurance as a first-class citizen in the development project. And what do I mean about when I say first-class citizen? Well, we need to move from testing being an external quality assurance entity towards being an integral part of the design and or the development process. And to do that, we need to claim our place in the process and in the team. So we joined code reviews, not necessarily reviewing the actual code, but more auditing code review processes to avoid body reviews. We can hear the discussions in the room where one developer is yelling to another, can you just approve my new code and we can get on with it? No, don't approve it, review it. Big difference. Also, immerse ourselves in the design discussions, like I mentioned in the previous slide, with testability and portability in mind. And also, in those design discussions, even if it's not connected to the portability and the testability, we listen very much to the tone of the discussions. If the developers sound a bit insecure about a solution, and after a while of discussion they just say, oh, let's try this one and see if it works. Then we'll say, well, maybe not try, maybe you should be more comfortable with your solution before trying it out. Because if you just try out a solution, then it's all up to the testing to make sure that it works later on. But if you design it thoroughly before testing it, we as testers only have to make sure that it works as it's supposed to work. We practice a lot of parallel implementation. We implemented the test framework and the test cases in parallel with the actual production code. So when a developer started out with a feature, he or her grabbed a test engineer, a test developer, and said, okay, we're starting on this feature now. Can we just look at it together and come up with a plan together and make sure that we understand the feature in the same way? And if they don't understand it in the same way, probably something's wrong with the requirements. So we need to go back and think more on those. And it also gave us the opportunity to test everything very, very early, so that before actually the code is in the main branch and the main product, we can test the feature, or the developer can test the feature with our framework on their computer before committing the code. We also promoted pair programming, and sort of in a new way. Pair programming, I think most of you know what it's about, but developers programming or developing together. And it's an old concept, nothing new. But we used it, we did pair programming with developers and testers. So not only did we program or develop in parallel, we also developed together. So that, for instance, when we wanted to make sure that the testability was up to par, and the developer was doing some new graphical GUI or user interface feature, and they wanted help with making sure that we could identify all the elements underneath to be able to automate our tests. The tester and the developer sat together for a while and developed the feature and made sure that every element is in the right place and easily testable and so on. And also the other way around, when we develop our test code and we need some help with using endpoints and so on, it might be tricky on a technical perspective, but then we sat developers and testers together developing the test code for that purpose, and that was a very strong concept. Another thing that we needed to do was to claim the right to quality, not to say that we want to do these steps to ensure the quality, or we might be able to do this, and can we get resources to do this, and can we get a separate environment to do this. We said that this is needed. For this feature, we need to do this, this, and this step. Otherwise, this feature won't get into the main branch. That's it. And for some reason, everyone accepted it. I don't know why. I still don't know why. But to be able to act as a first-class citizen in the development process, you cannot only take. You need to give as well. So we needed to show that we deserved that place in the team, and we did that by in a couple of ways. One is we tried to lead by example in our code quality. We had the same or higher standards on the code quality in the testing framework as we imposed on the actual production code. So we had code reviews. We used static testing tools to make sure that our code was up to par, and so on. And this was to be able to say that we won't accept issues in our code just as well as we don't accept issues in the production code. And another important point of gaining quality is gaining understanding of the product and all the environments around it and all the other parameters. And DevOps is an important part of any project, I would say, any software development project. DevOps for me is everything from deploying environments to monitoring servers to setting up rules for Git branches and so on. And being able to do this. In our team, I took the responsibility for this area as well. In the beginning, it was because I thought it was funny, or not funny, but fun at least. And it gave me an opportunity to learn new stuff. So I thought it was interesting. But after a while, I realized that actually, with my point of view, or a point of view of a tester, we can actually do more to the process and to the team than perhaps someone with a development background could do, because we have greater needs for more environments, and we have greater needs for understanding different aspects of combinations of issues and parameters and so on, to be able to troubleshoot and to be able to stress the system and so on. So if we as testers are the most demanding customer to DevOps, then perhaps we should take care of DevOps ourselves to reduce friction, if nothing else. So one part is, like I said, to understand everything, how things work together. Because for a developer, it's quite easy, from my perspective. It's more easy for the person who designed the system to know how it works. And instead of having to communicate all the details of how it works to the testers, and we can make sure that we set it up to work, and thereby understanding how it works. But also in line with making demands on the product. In being someone with a DevOps role, you can, in the tools you use, we use Microsoft's Visual Studio Team Services in combination with Git repositories, where we set up rules for how to introduce code to the master branch. And since I was the one with the administrative rights in the system, I could make the demand. So I changed the settings. So to be able to introduce new code, you need to go via pull requests, and in the pull request you introduce new code, and we deploy the new feature in an environment. We do run all our regression tests, and then we do code reviews. And to be able to approve a pull request, we needed approvals from 2 developers from code review and 1 from the testing team to either say that, okay, the test results are fine, go ahead. Sometimes it can also mean that, yes, we have developed all the tests that are needed, or if we decide that we don't need to add more tests, right now we can just continue with only regression tests and go on and approve the change. So we set those rules. And also, when it comes to monitoring, oftentimes when it comes to monitoring, it's most interesting in a developer perspective to make sure that we don't bog down the CPU too much. We don't use too much memory. We perhaps measure how fast the writing to a database is. But to end user is not really that interesting. Those numbers are really interesting for the team, and those numbers need to be presented. But we will also introduce, in our example, how long it takes for the entire buying of a ticket, from doing a search to choosing the alternatives. I'm an adult, I want to travel for 24 hours, and then click through the entire process, and how long it takes for the purchase to go through from an end user perspective. That type of KPIs. So adding DevOps as a quality assurance part also, I think, made those parts of the process more understandable from our perspective, and we could gain confidence in the quality in more aspects in that way. So on the first slide, it said going from fear to confidence. And we might ask, fear of what? Well, in this case, a week before our launch, this was in March this year, I realized that I was the one responsible for this. And that scared me. Really much. I mean, really scared me. And if it doesn't work, it just means that I didn't make a decent enough effort to make it work or to ensure the quality. So I needed to convince myself not to flee the country. And besides from reminding myself of all the other stuff that I've been talking about, I had 3 main points that convinced myself that I had done everything I could to share the responsibility. I was still main responsible for the quality, but I had to make sure that it hadn't been up to my own narrow imagination to come up with all of the ways we needed to test. It wasn't even limited to the imagination of the test team. we needed to share all the responsibility. So for that, we needed full transparency. As I said before, by being a first-class citizen, we need to make sure that our code is understood by everyone in the team. So all the other developers, apart from the test developers in the team, can understand and review and look at the test code. So if we feel that we are insecure in some area, we can ask the developers to look at the test code covering that area and ask them, do you feel comfortable with this? Sure, okay, good. Also code reviews, recurring code reviews. The code reviews are not only for the test developers. We invite also the production code developers to review the test code to make sure that everything is tested and assess the coverage. Also easy access. If the automated test system is easily accessible for everyone, then they can download the automation test framework and run tests locally to make sure that we can make, for instance, refactoring of code with confidence. We can make large changes in the code and make sure that it still works. Also, last point, acceptance test sessions. Acceptance tests for me traditionally is a huge process involving test suites that are exported to a customer, and the customer is supposed to run them, and etc. But we had to make that more efficiently and with faster feedback. So instead of having this large feedback loop, we tightened it down by having acceptance test sessions instead, where I invited customer representatives, other stakeholders. I invited the developers that were tightly involved with the features that we were supposed to review, a test developer that had been involved in testing the features, and myself, and perhaps a requirement specialist. And then we just used the features together with the customer and guided them through the process, getting feedback back instantly. It's like an intimate version of a sprint review. And at the end of this, we had a list of, and at the end of every such session, it was perhaps once a week, once every other week, once a month, depending on how many features we had developed. At the end of every one, we had a list of perhaps 20 issues. 15 to 18 of those were issues that the developers could fix within the next hour after the session was over. And the 2 or 3 or 5 rest of them were larger issues that we had to make formal bug reports out of. And then we can fix eventually. And that last point really increased the confidence and our understanding, both from the customer perspective. They understood our process, they understood the features we developed, and they also made us confident about the product that we made. And that is it. Any questions?